long before humanity built its first city, long before the first ship crossed an ocean, long before the first telescope was ever pointed toward the stars. The universe was already speaking, not with words, not with sound, and not in any language that a human mind could understand. Across the darkness between galaxies, invisible signals raced through space. Some traveled for millions of years. Others began their journey before entire civilizations on Earth had even existed. They crossed vast oceans of emptiness, slipping silently between stars, drifting through clouds of gas, passing ancient galaxies that would never know they were there. And eventually, a few of those signals arrived here. Not with a flash in the sky, not with a dramatic explosion, but as tiny disturbances hidden inside streams of data, small enough to be overlooked, strange enough to be dismissed, and mysterious enough to change astronomy forever. Tonight, we often imagine that the universe is silent. When we look up at the night sky, everything appears calm. The stars seem fixed, the darkness seems still, and the immense spaces between worlds appear empty. But appearances can be deceiving, because beyond the reach of our eyes, the cosmos is alive with activity. Dead stars twist powerful magnetic fields into impossible shapes. Invisible waves ripple across unimaginable distances. Ancient objects release bursts of energy so brief that they last less than the blink of an eye, yet powerful enough to be detected from the far side of the observable universe. Some of these signals have names. Some have possible explanations, and some continue to puzzle scientists even after years of study. The strange thing is not that we still have questions. The strange thing is that we can hear them at all. Human beings evolved beneath African skies. Our ancestors learned to survive by listening for footsteps in the grass, for storms in the distance, for the voices of other people. Nothing in our evolutionary history prepared us to listen to the universe itself. Yet somehow, through mathematics, engineering, and curiosity, we have built instruments capable of detecting whispers from across billions of light years. And what those instruments have discovered is both beautiful and unsettling, because the deeper we listen, the stranger the universe becomes. Some signals arrive only once and are never heard again. Some repeat with eerie precision, as though something in deep space is keeping time. Others seem to come from objects that should not even be capable of producing them. Each discovery brings us closer to understanding, yet each answer reveals new mysteries waiting behind it. Tonight, as we journey through deep space together, we will follow these signals across the cosmos. We will visit the remnants of dead stars, explore some of the most extreme environments known to science, and trace messages that began their journeys long before any human being was alive to receive them. Because somewhere, even now, while most of the world sleeps, the universe is still speaking, and we are only beginning to learn how to listen. Most discoveries begin with someone looking for something. A new planet, a new star, a new answer. But some discoveries arrive in a very different way, not as something sought, but as something stumbled upon. A quiet accident hidden inside an ordinary day. The story of one of the universe's strangest signals begins like that. Not with excitement, not with celebration, and certainly not with the feeling that history was being made. It began with a routine observation, the kind of observation that astronomers perform countless times every year. Far from the crowded cities of Australia, beneath wide southern skies filled with stars, a radio telescope spent its nights listening to the cosmos. Unlike optical telescopes, radio telescopes do not see the universe. They listen to it. They collect invisible waves arriving from every corner of space and transform them into data, endless streams of numbers, patterns, measurements. Most of it appears completely ordinary, a sea of information so vast that no human could ever examine every piece of it. Night after night, the telescope continued its work, listening, recording, storing, filling archives with signals from distant stars, galaxies, and objects too faint to ever appear in a photograph. And then, sometime during one of those observations, something happened. A signal arrived. Brief, powerful, unexpected. It appeared for only a tiny fraction of a second. Then it vanished. No alarm sounded. No scientist rushed into the control room. No newspaper headline announced its arrival, because nobody noticed it. The signal simply became another line of data among millions of others. It was stored away, archived, forgotten. For years it remained there, sleeping quietly inside magnetic storage systems, a message without a reader, a mystery without an audience. Meanwhile, life on Earth continued. People went to work, children grew older, new technologies appeared. Entire chapters of human history unfolded, and all the while, hidden in a database, waited a signal that had traveled across unimaginable distances only to be ignored upon arrival. There is something strangely poetic about that. We often imagine discovery as a dramatic moment, a scientist shouting with excitement, a sudden breakthrough, a flash of realization. But reality is often slower, more patient. Sometimes the universe sends an extraordinary message and waits years for someone to open it. Eventually, someone did. A group of researchers began examining old observations, not because they expected to find a revolutionary discovery, but because modern techniques allowed them to search through historical data more carefully than before. As they worked through countless recordings, a peculiar pattern emerged. One event stood apart from everything around it. At first glance, it looked impossible. A sudden burst, extremely bright, extremely brief, unlike the familiar signals astronomers were used to seeing. The more they investigated, the stranger it became. The signal appeared to have traveled through enormous quantities of matter before reaching Earth. Something about it suggested a journey far greater than anyone initially imagined. Not from a nearby star, not from somewhere inside our own galaxy, but from far beyond, possibly far beyond. If that interpretation was correct, then the implications were staggering. Whatever had produced the burst had unleashed an astonishing amount of energy. Not over years, not over days, but in a moment so brief that a human eye could never perceive it. For the scientists studying the data, a difficult question emerged. Had they discovered something real, or had they simply found a mistake? The history of astronomy is filled with false alarms. Instrument glitches, software errors, signals from satellites. Even ordinary technology on Earth can sometimes imitate cosmic events. Extraordinary claims require extraordinary caution. And so the researchers hesitated. They checked the data again, and again, and again. The signal refused to disappear. It remained there, waiting, persistent, unexplained, like a footprint left in fresh snow, evidence that something had passed by, but offering no clue about what had made it. Soon other scientists began paying attention. Discussions spread. Debates followed. Some remained skeptical. Others became fascinated. The possibility was difficult to ignore. Because if the signal was genuine, then humanity had just detected something entirely new. Not a new planet, not a new galaxy, but a new kind of cosmic event. A phenomenon no one had predicted. A voice from deep space, unlike anything ever heard before. And perhaps the most remarkable part of the story was this. The signal had arrived years earlier. The universe had spoken. Humanity simply hadn't been listening closely enough yet. But that was about to change, because the strange burst that had slept unnoticed inside an archive would soon become the first member of an entirely new family of cosmic mysteries. And once astronomers knew what to look for, they would begin finding them everywhere. Once scientists became convinced that the mysterious signal was real, another question immediately emerged. A far more unsettling question. Where had it come from? At first, the answer seemed almost impossible. The numbers suggested a distance so vast that many researchers struggled to believe it. Because if the calculations were correct, this brief flash had not originated somewhere nearby. Not from a neighboring star, not from a distant corner of the Milky Way, but from another galaxy, possibly billions of light years away. To understand why that was so astonishing, it helps to pause for a moment and consider what a light year truly means. Light is fast. In a single second, it can circle Earth more than 7 times. It races across space at a speed that seems almost magical from a human perspective. Yet even light requires time. Sunlight takes over 8 minutes to reach our planet. The glow of Jupiter arrives tens of minutes after it leaves. The nearest star beyond our sun is more than 4 years away at light speed, and our galaxy itself is so enormous that a beam of light needs roughly 100,000 years to cross from one side to the other. Already these distances are difficult to imagine. But the signal astronomers had discovered appeared to come from much farther away, far beyond the boundaries of the Milky Way, far beyond the familiar stars that decorate our night sky. Perhaps from a galaxy so distant that its light had begun traveling toward Earth long before many events in human history had occurred. Imagine that for a moment. Imagine receiving a message that began its journey before the construction of the oldest surviving buildings on Earth, before entire nations existed, before countless generations of human lives had been born and forgotten. A signal traveling through darkness while empires rose and fell beneath it, crossing cosmic voids so vast they make oceans seem insignificant, passing galaxies that appeared only as faint islands of light suspended in an endless sea of black. The journey alone feels almost impossible. Yet somehow, against overwhelming odds, the signal arrived. Not weakened into nothingness, not lost between galaxies, but strong enough for instruments on a small rocky world to detect it. That realization transformed the mystery. Because distance changes everything. A flashlight can appear bright from across a room, but if you move it thousands of miles away, it becomes invisible. The farther a signal travels, the more its energy spreads into space. So, if this burst truly originated billions of light years away and was still detectable when it reached Earth, then whatever created it must have been unimaginably powerful. Something out there had released an enormous amount of energy, and it had done so in less time than it takes to blink. For astronomers, this was deeply unsettling. The universe contains many powerful things: stars, black holes, supernova explosions, entire galaxies. But few known phenomena could produce such an intense flash so quickly. It was as if the cosmos had briefly ignited a lighthouse bright enough to be seen across the observable universe, then switched it off almost immediately. No lingering glow, no obvious explanation. Just a single pulse, a cosmic heartbeat. And then silence. As more observations accumulated over the following years, scientists began finding additional bursts, not identical, but similar. Each one appeared unexpectedly. Each one arrived from deep space. And each one carried the same fundamental mystery. What kind of object could generate such flashes? The growing collection of signals suggested that the first discovery had not been an isolated accident. There was a population of these events hidden throughout the universe, an invisible phenomenon taking place over and over again beyond the reach of ordinary human senses. The realization was both exciting and humbling. For centuries, humanity believed the night sky was mostly quiet. A vast backdrop of distant stars, beautiful, predictable, stable. But now, evidence was emerging that the universe was far more active than it appeared. Beneath the stillness of the night sky, powerful events were unfolding continuously. Invisible storms, violent eruptions, brief flashes of energy racing through intergalactic darkness. Most would never be noticed by human eyes. Many would pass Earth without detection. Others would arrive when no telescope happened to be listening. How many signals had already swept past our world unnoticed? How many had crossed our solar system thousands or millions of years before humanity even existed? No one could say. The thought is strangely comforting. Even while we sleep, even while cities fall silent, even while clouds drift above dark oceans and forests. The universe remains active. Stars continue to live and die. Galaxies continue their slow dance through space. And somewhere beyond the reach of sight, another mysterious signal may already be traveling toward Earth, a journey that began before recorded history, a journey that may not end for millions of years, a silent traveler crossing the darkness, carrying a story we have not yet learned how to read. And the deeper scientists looked into these signals, the more they began to suspect that the answer might involve some of the strangest objects ever discovered. The corpses of dead stars, objects so extreme that they challenge the limits of imagination itself. When most stars die, their stories slowly fade. They burn their fuel, they grow old, and eventually they disappear into the quiet rhythms of the cosmos. At least, that is what we might expect. But some stars refuse to leave so quietly. Some continue speaking long after their deaths. And among the strangest of them are objects so extreme that they seem almost impossible. To understand them, imagine a star far larger than our sun. For millions of years, it shines brilliantly. Its light pours into surrounding space. Its gravity holds entire planetary systems together. From a distance, it appears permanent, timeless. But deep within its core, a clock is ticking. Eventually, the star runs out of fuel. The delicate balance between gravity pulling inward and energy pushing outward begins to fail. For a brief moment, gravity wins. The star collapses. And then comes one of the most violent events in the universe. A supernova. An explosion so bright that an entire galaxy can briefly struggle to outshine it. For a few days or weeks, the dying star releases unimaginable amounts of energy. Then the fireworks fade. The expanding debris drifts outward. And what remains behind is something entirely different. Something much stranger. A neutron star. At first glance, the name sounds almost ordinary. But neutron stars are among the most bizarre objects known to science. Imagine compressing a mass greater than our sun into a sphere only about 20 kilometers across. A city-sized object containing enough matter to outweigh hundreds of thousands of Earths. Its gravity becomes so intense that reality itself begins to behave differently. A teaspoon of neutron star material would weigh billions of tons. A single step on its surface would be impossible. The gravity would crush you long before you could even comprehend what was happening. And yet, despite their incredible density, neutron stars are not black holes. They remain visible, active, alive in their own strange way. Many spin rapidly. Some rotate dozens of times every second. Others sweep beams of radiation through space like gigantic cosmic lighthouses. For decades, astronomers believed these extraordinary remnants were already among the most extreme objects in existence. Then they discovered something even stranger. A rare subgroup of neutron stars known as magnetars. If ordinary neutron stars are remarkable, magnetars seem almost unreal. They possess magnetic fields so powerful that comparison becomes difficult. Earth has a magnetic field. The Sun has a magnetic field. Even ordinary neutron stars possess magnetic fields beyond anything humanity could create. But magnetars exist in a category of their own. Their magnetic fields are so intense that they can reshape the environment around them, twisting, stretching, storing enormous amounts of energy. Imagine invisible lines of force tangled together under tremendous pressure, for years, centuries, perhaps millennia. Eventually, something gives way. The magnetic structure shifts, the star adjusts, and energy is released, not gradually, not gently, but suddenly, violently. For astronomers trying to understand mysterious signals from deep space, magnetars quickly became prime suspects. The idea was appealing. These objects were compact enough, powerful enough, and strange enough. If something in the universe could unleash an enormous burst of energy in a fraction of a second, a magnetar certainly seemed capable of doing it. Yet the deeper scientists looked, the more complicated the story became. Because magnetars are not simply machines that produce predictable signals. They are restless, unstable, temperamental. Some remain quiet for years, then suddenly awaken. Others produce bursts of X-rays and gamma rays without any obvious warning. Their behavior can change dramatically over surprisingly short periods of time. It is almost as though these dead stars possess moods. Long periods of silence interrupted by moments of extraordinary activity. And perhaps that is why they capture the imagination so easily. A black hole is mysterious because we cannot see inside it. A magnetar is mysterious because even when we can observe it, it refuses to behave in entirely predictable ways. It remains partly hidden behind its own complexity. Somewhere in the darkness of the universe, countless stellar remnants drift through space. Most are invisible. Many will never be noticed. But every now and then, one of them may release a burst powerful enough to cross entire galaxies. A flash lasting less than a heartbeat. A brief announcement of its existence. A reminder that even in death, stars can remain astonishingly active. And if magnetars truly are responsible for some of the strange signals reaching Earth, then we are not merely listening to distant objects. We are listening to the echoes of stellar catastrophes, the lingering voices of stars that died long ago. But as convincing as the magnetar explanation appeared, a surprising discovery would soon complicate everything. Because some of the mysterious signals were about to do something they were never expected to do. They came back, again, and again, and again. For a time, the mystery seemed to be taking shape. The strange bursts were powerful, brief, rare, and perhaps most importantly, they appeared only once. This led many scientists toward a logical conclusion. Whatever produced these signals might be destroying itself in the process. The burst could be a final act, a cosmic farewell. A last release of energy before an object vanished forever. The idea made sense. The universe is full of catastrophic events. Stars explode. Neutron stars collide. Black holes consume matter in violent outbursts. Many of the most dramatic events in astronomy happen only once. Why should these mysterious signals be any different? For several years, that assumption remained largely unchallenged. Each newly detected burst seemed to support the same picture. A signal would appear. It would be recorded, and then nothing. No second flash. No follow-up event, only silence. The case appeared straightforward, at least until the universe decided to complicate matters, as it so often does. Somewhere deep in space, one particular source had already attracted attention. Astronomers knew its location. They had recorded a strange burst from that region before. There was no reason to expect anything unusual. No reason to believe history would repeat itself. Yet one day, while examining fresh observations, researchers noticed something impossible. A familiar signal had returned. At first, the results seemed difficult to believe. The same region of space, the same characteristics, the same cosmic fingerprint. It could not be dismissed as coincidence. The source had become active again. The object responsible for the original burst had survived. And it was speaking once more. The implications spread through astronomy almost immediately. If the source was repeating, then entire categories of explanations suddenly became far less convincing. An object cannot destroy itself repeatedly. A star cannot explode over and over again. A final goodbye is only final once. The discovery forced scientists back to the beginning. Everything had to be reconsidered. The mystery was no longer about a brief cosmic catastrophe. Now it involved something persistent, something capable of awakening again and again. For the first time, astronomers could do something they had never been able to do before. They could wait. Instead of hoping to catch a random signal by chance, they could point their instruments toward a known location and listen. The strategy worked. More bursts arrived, then more and more. The source continued its strange behavior, sometimes active, sometimes silent, never predictable for long. The effect was almost eerie. Imagine hearing a voice from a distant mountain on a dark night. A single shout would be surprising enough. But imagine hearing it again weeks later, then again months after that. You would begin to wonder not only what was making the sound, but why. What determined when it spoke? Why did it remain silent in between? Was there a pattern hidden beneath the randomness? Astronomers found themselves asking similar questions. The more they observed, the more complex the picture became. Some repeating signals seemed calm for long periods, before suddenly entering bursts of activity. Others produced clusters of flashes, separated by stretches of silence. No two sources behaved exactly the same way. The universe was not offering a simple answer. It was offering a collection of clues. And like all good mysteries, the clues seemed to multiply faster than the explanations, yet something important had changed. The signals were no longer anonymous. Before, scientists had only brief glimpses, a flash, a detection, a mystery. Now they had behavior, patterns, histories, personalities almost. Each repeating source began to feel less like an event and more like a character in an unfolding story. One source might remain quiet for months, before suddenly releasing dozens of bursts. Another might produce only occasional flashes. Some seemed energetic and chaotic. Others appeared almost disciplined. It was as though different objects across the universe were speaking in different dialects of the same strange language. And perhaps the most fascinating question of all remained unanswered. Were all these signals truly related? Or were astronomers accidentally grouping together completely different phenomena simply because they looked similar from far away? The possibility was unsettling. Imagine hearing distant sounds through a wall, a laugh, a knock, a melody, a whisper. At first, they might seem connected. But once the wall is removed, you discover they came from entirely different sources. Something similar may have been happening with these cosmic signals. The more examples scientists collected, the more diversity they found. Some repeated, others did not. Some appeared extraordinarily energetic, others seemed comparatively modest. Some came from environments rich with young stars. Others emerged from places where such activity should have been impossible. Instead of solving the mystery, repetition made it larger. The universe had transformed a single question into many, and hidden among those questions was another discovery waiting to be made, because a few of the repeating signals would soon reveal something even stranger. They were not merely repeating, they were keeping time, like clocks hidden in the darkness between the stars. Human beings have always been fascinated by rhythm, the rising and setting of the sun, the changing of the seasons, the steady ticking of a clock in a quiet room. There is something comforting about repetition, something reassuring about knowing that certain things will happen again. Tomorrow follows today, night follows day. The universe, however, is not always known for being predictable. Supernovas erupt without warning. Asteroids wander through space. Stars are born and die over timescales so vast that they seem almost timeless. Yet, among the mysterious signals arriving from deep space, astronomers began noticing something unexpected. Some of them appeared to follow schedules. Not perfect schedules, not the precise ticking of a mechanical clock, but patterns that repeated often enough to demand attention. At first, the evidence seemed almost too strange to accept. The bursts themselves remained brief, just flashes, tiny moments of activity. But when scientists stepped back and looked at them over months and years, a larger rhythm began to emerge. Certain sources appeared active for a period of time, then silent, then active again, as though something unseen were opening and closing a door. One of the most remarkable examples seemed to follow a cycle lasting just over 2 weeks. For several days, bursts could be detected, then nothing. The source would fall silent, the darkness would return, days would pass. And then, almost as if obeying an invisible calendar, the activity would begin once more. The pattern repeated again and again, not perfectly, but consistently enough to suggest that chance alone was unlikely to be responsible. This raised a fascinating possibility. Perhaps the source itself was not changing. Perhaps something around it was. Imagine a lighthouse hidden behind drifting clouds. The light remains active the entire time. But from your perspective, it appears only when the clouds move aside. Could something similar be happening in deep space? Maybe the source was constantly producing signals. Maybe an orbiting companion periodically blocked them from view. Or perhaps some invisible structure surrounding the object changed over time, alternately revealing and concealing the bursts. No one knew for certain, but the discovery introduced an entirely new idea. Some mysterious signals might not be random at all. Some might possess a rhythm, a heartbeat, a schedule, a clock. And then came an even stranger realization. Not all cosmic clocks ticked at the same speed. Some signals seemed to repeat on timescales measured in days. Others hinted at rhythms lasting weeks. And beyond the world of fast radio bursts, astronomers began discovering objects behaving in ways that seemed even more impossible. Signals arriving every 20 minutes, every 30 minutes, sometimes even longer. These were not ordinary pulsars, not according to established theory. For decades, astronomers believed they understood the limits of how certain stellar remnants should behave. A spinning neutron star could produce pulses. That much was familiar. But only within a particular range. Slow the rotation too much and the signal should disappear. The engine should shut down. The lighthouse should go dark. Yet, observations suggested otherwise. Some objects appeared to be pulsing at rates that should have been impossible. They continued speaking long after theory predicted they should have fallen silent. Like ancient clocks that kept ticking despite broken gears, the implications were profound. Not because scientists had discovered something supernatural, but because nature once again seemed more imaginative than human expectations. This has happened throughout the history of astronomy. Each time we become confident that we understand the boundaries of possibility, the universe quietly places something unexpected just beyond those boundaries. A planet where none should exist, a black hole larger than anticipated, a signal arriving from an environment that should not be capable of producing it. The cosmic clocks belong to this tradition. They reminded us that knowledge is rarely a finished structure. It is a map. And every new discovery reveals territory beyond its edges. For the scientists studying these signals, the clocks presented both an opportunity and a challenge. Patterns are valuable. Patterns can be studied. Predictions can be tested. The next burst might be anticipated. The next observation planned. For the first time, some mysterious signals were becoming less like random interruptions and more like ongoing conversations. Yet every answer seemed to create another question. What was keeping time? What mechanism governed the rhythm? Why did some sources appear chaotic while others displayed remarkable regularity? And perhaps most intriguingly, who, or rather what, was winding these cosmic clocks? Somewhere in the darkness hidden among billions of stars, objects were following schedules older than human civilizations. Schedules that continued uninterrupted while kingdoms rose and fell, while continents changed, while generations came and went. Their rhythms belonged not to humanity, but to the universe itself. And while astronomers struggled to understand these clocks, another signal would soon appear that seemed determined to break every expectation once again. Because if some of the strange bursts were rhythmic, and some were repeating, one signal would arrive with a different distinction altogether. It would become the brightest radio flash ever detected. A burst so powerful that, for a brief moment, it would stand above every mysterious signal that had come before it. And then, just as suddenly as it appeared, it would vanish. Most mysteries announce themselves quietly. A strange observation, an unusual pattern, a small inconsistency hiding inside a mountain of data. But every now and then the universe abandons subtlety. Instead of whispering, it screams. Somewhere in a distant galaxy, far beyond the reach of the naked eye, an event occurred that would eventually become one of the most extraordinary radio signals ever recorded. For less than a heartbeat, something unleashed an immense burst of energy. Then it was gone. The flash itself was astonishing, but what made the event truly remarkable was how bright it appeared, despite the unimaginable distance separating it from Earth. By the time the signal reached our planet, it had already traveled for millions upon millions of years. It had crossed intergalactic darkness, past countless stars, moved through vast regions of space so empty that a human mind struggles to picture them, and yet it remained powerful enough to stand out from every other signal around it. Imagine standing alone on a beach during a stormy night. Waves crash in every direction. The wind fills the air with noise. Then suddenly, from somewhere beyond the horizon, a single flash of light erupts brighter than anything else in the sky. Not for long. Just long enough to make you stop breathing for a moment. That was how this signal felt to astronomers. A brief interruption in the ordinary background of the cosmos. A flash impossible to ignore. The event quickly attracted attention from observatories around the world. Scientists wanted answers. What kind of object could produce such an enormous release of energy? What environment could support such an event? And perhaps most importantly, would it happen again? The source appeared to offer an incredible opportunity. Unlike many mysterious signals detected from the distant universe, this one originated relatively close by on cosmic scales. Close enough that researchers could study its surrounding environment in extraordinary detail. Telescopes turned toward its home galaxy. Sensitive instruments searched for clues. Astronomers examined nearby stars, clouds of gas, and anything else that might reveal the nature of the source. Piece by piece, a picture began to emerge. The signal appeared to have originated from a region where stars were actively being born. A place filled with youthful energy. A place where massive stars lived short and dramatic lives. At first glance, this seemed encouraging. Perhaps the mystery was finally becoming easier to solve. Perhaps this extraordinary burst came from a young magnetar, or some other recently formed stellar remnant. The environment seemed compatible with that possibility. The clues appeared to fit, but then something unexpected happened. Nothing. Days passed. Weeks passed, months passed. The source remained silent. Observatories continued listening. The universe offered no response. The brightest signal ever recorded had vanished as completely as it had appeared. This silence proved almost as fascinating as the burst itself, because many other mysterious radio sources had eventually repeated. Some had spoken dozens of times, others hundreds. A few had become familiar visitors in astronomical data. But this source remained stubbornly quiet. It was as though the universe had delivered an extraordinary message and then immediately hung up the phone. No explanation, no follow-up, no second chance to observe the event directly. The contrast was striking. Elsewhere in the cosmos, repeating sources seemed eager to continue the conversation. This one delivered a single unforgettable sentence and disappeared. And that raises a question that remains deeply intriguing. What if not all mysterious signals come from the same kind of object? What if astronomers are listening to an entire orchestra while trying to identify a single instrument? Some bursts may come from young magnetars. Others may involve binary systems. Some may result from rare cosmic catastrophes that occur only once. The brightest signal ever heard seemed to hint at that possibility. It reminded scientists that nature rarely organizes itself according to human categories. We prefer neat explanations, clear definitions, simple boxes. The universe often prefers complexity, and perhaps that is why these signals remain so captivating. Each new discovery reveals another layer of the story, a layer that feels understandable at first, until a new observation arrives and changes everything again. The loudest signal ever detected was not merely a powerful flash. It was a reminder that the cosmos still contains events unlike anything we have fully understood. And while astronomers searched for answers, another category of signals was quietly creating an even deeper problem. Because some objects were doing something that should not have been possible at all. They were producing regular pulses on timescales that violated decades of accepted theory. Not seconds, not milliseconds, but minutes, sometimes even hours. And according to everything scientists thought they knew, those signals should not have existed. Science often advances through surprise, not because scientists are wrong, but because nature is larger than any theory we build to describe it. Again and again throughout history, the universe has presented humanity with something unexpected. A planet where no planet should survive, a black hole larger than anyone predicted, a galaxy older than expected, and sometimes, a signal that should not exist at all. For decades, astronomers believed they understood a particular kind of cosmic lighthouse, neutron stars, the collapsed remnants of massive stars. These extraordinary objects spin through space, sweeping beams of radiation across the universe like rotating searchlights. Each time the beam crosses Earth, our instruments detect a pulse, a rhythm, a heartbeat, a signal. The idea is simple enough. A rapidly spinning object creates a repeating pattern. The faster it spins, the more frequently we receive its pulses. And over time, as energy is lost, the rotation gradually slows, like a spinning top, eventually coming to rest. According to established theory, there is a limit. Slow the rotation enough, and the engine should stop. The pulses should disappear. The lighthouse should go dark. For many years, observations seemed to support that picture. Everything fit. Everything made sense. Then the universe quietly disagreed. It began with a signal unlike any that astronomers had encountered before. The pulses were not separated by seconds, nor fractions of a second. Instead, they arrived many minutes apart. At first glance, the discovery appeared almost absurd. It was like finding a hummingbird beating its wings once every hour. The behavior contradicted expectations so completely that researchers initially struggled to explain it. Perhaps there was an error. Perhaps the signal came from Earth. Perhaps some piece of equipment had malfunctioned. These possibilities had to be considered first, because extraordinary claims demand extraordinary caution. Yet, the signal remained. Careful analysis confirmed it. The pulses were real, and they were coming from deep space. The discovery was unsettling, not because the signal itself was dangerous, but because it challenged assumptions that had remained largely unshaken for decades. The object seemed to be operating far beyond the boundaries that theory considered possible. And then another source was discovered. Then another, and another. Slow pulses, long intervals, mysterious behavior. One object appeared to emit a signal roughly every 20 minutes. Another followed a different rhythm. Some remained visible for extended periods. Others seemed to vanish almost as quickly as they appeared. The growing collection became known as long-period radio transients, a technical name for a profoundly strange phenomenon, because beneath the scientific terminology lay a simple truth. Nobody knew exactly what they were. Imagine walking through an ancient forest at night. Every sound around you is familiar. Wind in the leaves, distant water, the occasional call of an animal. Then suddenly you hear something entirely unexpected. A rhythmic knock, slow, deliberate, repeating at regular intervals. You listen. The sound continues. Not random, not chaotic, but purposeful. You may not know what is producing it, yet you know it deserves attention. That is how these signals felt to astronomers. The universe was producing rhythms that did not fit comfortably within existing categories. And whenever nature refuses to fit our categories, discovery is usually close behind. The challenge was that every explanation seemed incomplete. Some researchers proposed unusual neutron stars. Others suggested exotic magnetic interactions. Still others explored the possibility of binary systems, pairs of stars locked in orbital dances around one another. Perhaps the signals were not being produced by a single object at all. Perhaps they emerged from interactions between two cosmic partners endlessly, circling through the darkness. The idea had a certain elegance. Two objects, one orbit, a repeating rhythm, a natural clock hidden in space. Yet even this explanation struggled to account for every observation. Some sources behaved differently from others. Some remained active for years. Others disappeared. A few seemed almost stable. Others appeared unpredictable. The more examples astronomers discovered, the harder it became to believe a single explanation could describe all of them. And perhaps that realization was the most important clue of all. Maybe the universe was not presenting one mystery. Maybe it was presenting several. Different phenomena, different objects, different engines, all producing signals that looked similar from a great distance. The cosmos has done this before. A distant light may appear identical to another light until closer examination reveals entirely different origins. A candle and a lighthouse can seem alike across an ocean. Only proximity reveals the truth. The same may be true here. Some mysterious signals may come from dead stars, others from binary systems, others from mechanisms that scientists have not yet imagined. The deeper we look, the more possibilities emerge. And that realization carries an unexpected beauty, because every unexplained signal represents an opportunity. A doorway, a reminder that the universe remains unfinished from our perspective. There are still chapters we have not read, objects we have not identified, processes we do not yet understand. Even now, while telescopes continue scanning the sky, another impossible signal may already be waiting to be discovered. A pulse hidden among billions of measurements, a pattern no one has recognized yet. A clue to a mystery that has not even been named. And perhaps the strangest part of all is this. These signals may not simply be telling us something about distant stars. They may be revealing something about ourselves, about the limits of human knowledge, about the assumptions we carry into every observation. Because whenever the universe surprises us, it forces us to confront a difficult truth. The cosmos is under no obligation to behave the way we expect. And nowhere is that truth more evident than in the signals that continue arriving from the darkness. Signals that challenge our models. Signals that refuse simple explanations. Signals that remind us how much remains unknown, which raises an even deeper question. What if these mysterious transmissions are not all coming from the same kind of source? What if the universe is not speaking with one voice, but with many? Human beings are natural pattern seekers. We look at scattered pieces and try to build a single picture, a single explanation, a single story. It is one of the reasons science has been so successful. When planets move according to the same laws, when stars are born through similar processes, when gravity behaves consistently across the cosmos, a unified explanation becomes possible. But every so often, nature resists simplicity, and perhaps the mysterious signals from deep space belong to that category. For years, astronomers searched for one answer, one source, one mechanism, one cosmic engine powerful enough to explain everything. It seemed reasonable. After all, the signals shared certain characteristics. They were brief, energetic, mysterious. And they arrived from distant regions of the universe. Surely they were all connected. Surely there was one hidden explanation waiting to be discovered. Yet the more observations accumulated, the harder that assumption became to defend. Some signals repeated, others never did. Some emerged from regions crowded with young stars. Others appeared in ancient environments where such activity should have been rare. Some behaved like clockwork. Others seemed entirely unpredictable. The similarities remained. But so did the differences. And gradually, a new possibility began to take shape. What if astronomers were not studying a single phenomenon? What if they were listening to several different phenomena at once? Imagine standing on a hill overlooking a distant city at night. The sounds drifting toward you blend together. A train whistle, church bells, traffic, music from an open window. At first, the noises seem like one continuous sound. But as you listen more carefully, distinctions emerge. Different sources, different purposes, different stories. Perhaps the universe is similar. Perhaps the signals we detect are not a single language. Perhaps they are many languages overlapping across unimaginable distances. One signal may come from a restless magnetar twisting its magnetic fields into violent configurations. Another may emerge from two stars orbiting each other in a cosmic dance. Another may originate from a phenomenon not yet recognized by science. Different voices, different origins. All reaching us through the same medium, radio waves crossing the darkness. There is something strangely beautiful about this possibility, because it transforms the universe from a machine into a conversation. Not a conversation directed at us, not messages intended for human ears, but conversations occurring naturally between matter, energy, gravity, and time itself. The cosmos speaking through its own processes. A neutron star speaks through magnetic violence. A binary system speaks through orbital rhythm. A black hole may speak through jets of accelerated particles. Entire galaxies speak through light. Every object contributes its own voice to the larger symphony. Most of those voices remain beyond human hearing. We perceive only tiny fragments, small pieces translated into data by our instruments. And yet, even those fragments reveal astonishing complexity. The deeper astronomers listen, the less the universe resembles a silent void. Instead, it begins to resemble a living landscape of activity. Invisible, vast, constantly changing. Imagine drifting far beyond the Milky Way. Far beyond any familiar star, suspended in complete darkness. At first, everything might appear empty, but then instruments begin translating the invisible. Signals emerge, pulses, flashes, rhythms, echoes. The darkness is suddenly alive, not with sound as humans understand it, but with information, with events, with activity occurring across distances so immense that language itself struggles to describe them. Perhaps this is why the study of these mysterious signals feels so captivating, not because they promise easy answers, but because they reveal a universe richer than expected. Every new signal expands the story. Every unexplained observation reminds us that reality is larger than our current understanding. And maybe that has always been the true value of discovery. Not simply finding answers, but discovering better questions. The history of science is filled with moments like this. Moments when certainty gives way to curiosity, when old maps become too small, when familiar categories begin to break apart. The mysterious signals of deep space seem to belong to that tradition. They remind us that knowledge is not a destination. It is a journey that moves outward with every observation, every telescope, every generation. And perhaps one day, decades from now, future scientists will look back on these mysteries with the same clarity that modern astronomers view puzzles of the past. Perhaps they will understand exactly how these signals are created, why some repeat, why others vanish, why certain objects behave like clocks while others erupt like cosmic storms. Perhaps the answers already exist, hidden somewhere within observations that have not yet been collected. But tonight, those answers remain unfinished, and there is something profoundly comforting about that. Because an unfinished mystery means the story continues. The universe is still revealing itself, still surprising us, still offering glimpses beyond the edge of current knowledge. And among all those mysteries, there is one realization that may be the most extraordinary of all. Some of the signals reaching Earth today began their journey so long ago that the objects that created them may no longer exist. In a very real sense, we may be listening to ghosts. When we look at the night sky, it is easy to forget a simple fact. We never see the universe as it is. We only see it as it was. Every beam of light requires time to travel. Every signal must cross distance. And distance in the universe is another word for the past. The moon we see tonight is not the moon of this exact moment. It is the moon from a little over a second ago. The sun shining through a morning window is already more than 8 minutes old. Even the nearest stars belong to years that have already passed. Astronomy, in a sense, has always been the study of history. Every observation is a glimpse into another time. Every telescope is a machine built to look backward. And nowhere does this become more profound than when we consider the mysterious signals arriving from deep space. Some of these signals have traveled for millions of years. Others may have crossed hundreds of millions. A few may have begun their journeys before entire branches of human civilization existed. Think about that for a moment. Imagine a signal leaving its source while ancient forests covered regions that are now cities. While mammoths still walked across parts of Earth. While generations of future human beings remained completely unimaginable. The signal begins its journey. And then it travels, year after year, century after century, millennium after millennium, crossing darkness so vast that even light, the fastest thing in the universe, requires ages to traverse it. All the while, the universe changes around it. Stars are born, stars die, galaxies collide, planets form, entire worlds appear and disappear. Yet the signal continues, silent, unstoppable, moving toward a destination it could never know. Eventually, after a journey almost beyond comprehension, it reaches Earth, a tiny blue world orbiting an ordinary star, a world where intelligent life has only recently learned how to listen. And suddenly, after millions or billions of years, the journey ends. A telescope records a pulse, a computer stores a measurement, a scientist notices an unusual pattern. That is all. The signal's immense voyage concludes as a line of data on a screen. There's something deeply moving about that, because it means some of the events we observe today may no longer exist. The star that produced the signal may be gone. The environment surrounding it may have changed completely. An entire chapter of cosmic history may have ended long before the signal reached us. We are witnessing echoes, not the present, not even the recent past, but fragments of ancient moments finally arriving after extraordinary journeys. In that sense, astronomy often resembles archaeology. An archaeologist uncovers traces of civilizations long vanished. Astronomers uncover traces of events long concluded. Both are searching for stories preserved across time. The difference is that cosmic history is written across distances so immense that human language struggles to capture them. When we detect a mysterious signal from deep space, we are not merely observing an event. We are receiving a message from another era, not a message intended for us, but a physical record of something that once happened, a flash, a pulse, a brief moment of activity preserved by the speed of light itself. Perhaps this is why the universe often feels so haunting. Not frightening, but haunting. The night sky is filled with ghosts, not supernatural ghosts, but historical ones, ghosts of vanished stars, ghosts of ancient explosions. Ghosts of galaxies that looked very different when their light first began traveling toward us. Every point of light carries memory. Every signal carries history. And every observation reminds us that time behaves differently on cosmic scales. Human lives are measured in decades, civilizations in centuries, but the universe thinks in millions and billions of years. Against such scales, even entire civilizations become brief moments, a blink, a passing thought. And yet, despite our smallness, we have reached a remarkable point in our story. We have become capable of hearing these echoes, capable of detecting traces of events that occurred long before humanity existed, capable of reconstructing histories written across the cosmos itself. That achievement is extraordinary, not because it grants us mastery over the universe, but because it connects us to something larger. A story still unfolding, a story whose earliest chapters began long before our species appeared, and whose final chapters may be written long after we are gone. Perhaps that is the deepest lesson hidden within these mysterious signals. They remind us that we are participants in a much larger timeline, a timeline stretching across billions of years, a timeline in which stars live and die, galaxies evolve, and signals travel through darkness for ages before finally finding an audience. Tonight, Somewhere beyond the reach of every city light on Earth, another signal is already moving through space, crossing the silent gulf between galaxies, carrying the imprint of an event from a distant past, traveling toward a future destination, perhaps toward another civilization, perhaps toward nothing at all, and perhaps, many millions of years from now, someone else will receive it, pause, wonder, and realize they are listening to a ghost. But if these signals teach us anything, it is that the universe has never truly been silent. The mystery is not whether it speaks. The mystery is whether we are listening carefully enough to understand what it is saying. As our journey through these mysterious signals comes to an end, it is worth returning to a simple idea. The universe has never been silent. Long before the first human looked up at the stars, long before the first telescope was built, long before the first question about our place in the cosmos was ever asked, the universe was already active. Stars were being born inside vast clouds of gas. Galaxies were drifting through darkness. Black holes were feeding. Planets were forming. And countless signals were crossing space. Unseen, unheard, unknown. For most of human history, we lived beneath this activity without realizing it existed. The night sky appeared calm, peaceful, almost motionless. Yet hidden beyond the reach of our senses, the cosmos was carrying on an endless conversation. A conversation conducted through light, through gravity, through radiation, through signals that could travel for millions or even billions of years before reaching their destination. Only recently have we learned how to listen. And what we discovered was not certainty. It was mystery. The deeper we listened, the more complex the universe became. Strange flashes appeared from distant galaxies. Dead stars continued speaking long after their deaths. Invisible clocks ticked in the darkness. Signals arrived from places that challenged our expectations, and each answer seemed to open the door to another question. Perhaps that should not surprise us. After all, every generation has believed it was approaching the edge of knowledge, only to discover another horizon beyond it. The universe is vast enough to accommodate both understanding and mystery. It allows us to learn, but it rarely allows us to finish learning. Even tonight, while you rest, observatories around the world continue their quiet work. Radio telescopes listen patiently beneath the stars. Sensitive instruments collect streams of data from the depths of space. Somewhere in those streams may be another unexplained signal, another puzzle, another clue, another voice waiting to be recognized. Perhaps tomorrow it will be discovered. Perhaps decades will pass before anyone notices it. Or perhaps it will remain hidden until future generations develop better tools and ask better questions. The universe is patient. It does not hurry. It does not demand immediate understanding. Its signals travel across ages. It can wait. And maybe that is one of the most comforting lessons hidden within these mysteries. Not everything must be understood immediately. Not every question requires an answer tonight. Some stories unfold slowly. Some journeys take time. Some signals travel for billions of years before reaching a listener. As you imagine the darkness beyond our world, picture the countless messages still moving through space at this very moment. Ancient flashes crossing between galaxies, invisible waves drifting through cosmic voids, echoes from stars that no longer exist, stories still in transit. Some may eventually reach Earth, others may wander forever through the darkness. But all of them belong to the same vast universe we call home. A universe that remains far stranger, far older, and far more beautiful than we can fully comprehend. And perhaps, somewhere beyond the distant stars, another signal has already begun its journey. A brief pulse, a tiny flash, a whisper from an unseen corner of the cosmos, traveling silently through the dark, crossing unimaginable distances, patiently making its way toward the future. Maybe one day someone will hear it. Maybe one day someone will understand it. But tonight, it continues its journey. And the universe continues speaking, as it always has, as it always will. Good night.